Beginning the homework from yesterday, I wanted to go through all the problems and make sure that they make sense. So we'll start with the E&M problems, the multiple choice. So we have the circuit below, and we want to know the potential difference between points A and B. We're going to use Kirchhoff's law. So we notice that there's a 40-volt battery here. And then there's the voltage drop across the 10-volt resistor, which is or 10-ohm resistor, which is exactly what we want to solve for here. Now this 2.5 amps, it came out of the battery, and when we realized that all these branches work the way they do, this 2.5 amps also has to go back into the battery, which means that it passes through whatever this resistor is too. So we don't know all the resistors, so we can't take that approach. So let's try a different approach. Let's see. We know also that since there's 2.5 amps here and only 0.5 amps here, 2.0 amps has to go down here because this 2.5 amps splits off into the 2.0 amps here and the 0.5 amps there. That's how current works. It splits off into those two pieces. So what that means is that we're going to get 20 volts going across the 10 ohm resistor. And again, that's because this 2.5 amps splits off into the 2.0 amps here and the 0.5 amps there. All right, we have a 0.2 microfarad capacitor and a 0.1 microfarad capacitor, and they're in parallel. So I'll call this C1 and I'll call this C2. And we've got a 6-volt battery. So the potential difference across the 0.2 microfarad capacitor is going to be just about 6 volts since they're both in parallel with the battery. Continuing on, a charge Q is placed at the center of a cube. We want to know the flux through one face of the cube. Well, we talked about this very briefly in class, but the electric flux is basically the charge enclosed by an object divided by epsilon naught. And since one face of the cube represents 1/6, that means the flux is going to be 1/6 of the total cube. All right, so that's C. Now for that's number 22. Now for number 11, we have two charges, and we want to figure out where the electric field will be 0. It says force, but a test charge placed at a point, that's how we determine an electric field. So just to be clear, C, D, and E don't even work. We can cross those out right away. Let's talk about why. It's because the electric field goes from positive to negative. So everywhere in between here, we're getting repelled by the +4 and attracted to the negative Q. So what that tells us is here, between these two charges, you're just not going to get a field that cancels. All right. So what that leaves us is we got to check out points A and B. Let's check A first. So let me just units of measurement here in terms of just these little gaps, or whatever they're called, ticks. So 1, 2, 3, 4, 5, 6, 7, 8. There's 8 ticks between A and negative Q, and 16 ticks between A and +4. So let's write the field down for A as negative Q over 8 squared, and then we'll add to that +4Q over 16 squared. And when we work that out, that's going to be negative Q over 64 plus Q over 64, which gives us 0 for the field. So that's how we're getting A. Next, we have a parallel plate capacitor connected to a battery until fully charged. If the battery remains connected while the separation between the plates is increased, which of the following remains constant? So we're connected to a battery. We're going to remain connected to the battery. So it's like we have this 4-volt battery, let's say, and we have a capacitor here. And then we just move the plates further apart, but we're still connected to the 4-volt battery. Well, our voltage stays the same. All right. Lastly, for this one here, and that's choice A. And then for this one here, we have a thin ring. So we're going to actually prove this today. But it turns out in this situation we're going to get KQ over R is the voltage, where R here is going to be this X, and this is R here. R is going to be X squared plus R squared under a square root. Write that better. Equals X squared plus R squared under a square root. all under square root. So here's the thing. We're going to put r in for x and 2r in for x, and we're going to actually calculate the work as q times delta v, which is going to be the same as the kinetic energy. So we measure v here versus v here, and we're going to get choice E as our answer. This one we're going to actually work out in more detail. So those are the E and M questions. We'll take a look at the mechanics questions in the next video.